What is going on, guys? First off, I hope everyone is safe and well. I've got a wonderful video for you guys today. Today we're going to be going over the amazing YOLO version 4, which if you are unaware of, it came out late last month. It's a heck of a lot faster than YOLO version 3 and more accurate, and it has a lot of new features and parameters. So we're going to be covering that today and how to run it in the cloud utilizing a free GPU. That's right, if you're stuck without a GPU, that is no longer a problem. We have a free GPU in the cloud, and we're going to be running this in Google Colab. I'm going to show you guys how to install all the dependencies, get everything up and running. It's similar to a previous video I did on YOLO version 3, but this one has a lot more in store for you guys. You guys are going to be able to run on video in the cloud, as well as have a lot more parameters, multiple images you can run it on at once, and stuff like that. We're going to be taking advantage of the new YOLO version 4 weights, and we're going to be running our own detectors in the cloud, totally for free. So I hope you guys follow along and enjoy the video. It's going to be a pretty packed one with info, so stick around for the whole thing and let me know what you think down below in the comments. It means a lot. Thanks. So in order to access the notebook itself and to follow along, there's two ways you can do so. The first is to click on the link in the description for the notebook, and it'll pop up something like this, and then all you're going to do is go ahead and click Open in Playground, and once you click that, it'll go ahead and bring you into a version that you can actually connect to a runtime and access the GPU and run the notebook yourself. And I recommend then just copying it to the drive, and that'll prompt you to log into your Google Drive and actually save the Colab notebook that you're working on in your own Google Drive. So if you don't have a Gmail account, it's easy to set one up. And I don't even know if you need a Gmail account to connect to Google Drive. You might be able to sign up with a regular account. So that's the first method. It's just click on the link and then Playground and copy to Drive, and then you can follow along here. And then the second method is actually to just go to the repository, the AI Guys code, YOLOv4 cloud tutorial, either clone or download the repository and all the code as a zip file. And actually you can access all the images and videos that I use in this tutorial right here. You can download the exact images I use and the videos I use to follow along exactly as I do. And everything else you can find is here. And then you download it or clone it, and then you just open up Google Colab and go to File and upload the notebook file. And then you will have it here as well. You might miss some of the photos as they might not upload properly straight from the GitHub repository. So I recommend the Google Drive method. But once again, it's always good to have the exact images and videos that I follow along with. So either of these two methods works. Alright, so first things first, to get the most out of this tutorial, you're going to want to enable your GPU, your free GPU, in order to run YOLO version 4 with GPU acceleration and have it run up to 100 times faster than if you didn't enable GPU. So I have some pictures here to show how to do that, but I'm just going to show you quickly. So you go to Edit, Notebook Settings, and then this will be set to none, and you're going to go GPU and save, and then it's going to go up here and say connecting, initializing, and then if you see this check mark with RAM and disk, it means you successfully enabled your GPU, and you're now good to go with the rest of the tutorial. So after that, we're going to clone and build Darknet. This is the famous framework that allows us to actually run our YOLO detections. So it's pretty easy and quick. It's just a couple commands here, just these 4 commands. And if you want, you can just go to runtime and run all, and that'll actually start kicking off running all the cells. Otherwise, you're going to have to go up in this corner and click the play button, and that will run one cell at a time. But if you click the runtime run all, kind of speeds it up a bit. So it's cloning in Alexei B's famous Darknet repository, which has all the code. And then we're going to go and change the makefile. So if you actually go to the files now, Darknet wasn't here originally, but we've cloned it in to our cloud VM, our Colab workspace, and we now have Darknet and all the code. And this makefile is what actually builds Darknet from the binary files, and allows us to then have an executable that we can call to run YOLO detections. So this second cell actually just inline changes and enables OpenCV and then also GPU. So it's going to build Darknet with GPU acceleration. So that's going to go ahead and allow us to run all of our detections much, much faster. And then we're just verifying that we have CUDA. I indeed have CUDA version 10.1 on your Google Colab workspace. So you all should also have either 10.0 or 10.1. It doesn't matter. And then this last make command is actually what builds Darknet for us so that we can run YOLO. And there might be a bunch of warnings, but don't worry. That's normal, and it is still going to work. So once it's done, we're going to let it finish, and then we're going to download the pre-trained YOLO version 4 weights. So YOLO version 4 was actually pre-trained on 80 classes of the coco dataset, which is a huge dataset of over millions and millions of images. So it's already trained on 80 classes, and it allows us to easily just grab the weights and begin running YOLO version 4 detections. So that's what we're going to do. So it's really quick. It went and got it. Perfect. We should be able to see if we close the Darknet and open it again. We now have YOLOv4.weights, so it's already now in with our Darknet folder. So that's good to go. Then after that, we define a couple helper functions that if you saw my previous video, you'll be aware of. So imshow allows us to open images within Google Colab because the native OpenCV viewing of images doesn't work. We get a warning, so we have to write our own function. And then there's also this upload function, which allows us, you'll see later, to upload a file from your local machine, and as well as download, which allows you to download a file to your local machine. So now that we have that, our next step is to run our detections with Darknet and YOLOv4. So it's really quick. You can see we're already to the step where we're about to run detections. And you can actually go ahead and see all the different classes that come pre-trained. So if you just click on these, or hover over them, it'll show you what you can detect. So with bird, dog, horse, you can just go through and play around. So you might not even have to create a custom detector. It might already be included in the coco dataset, which is huge. So now, if you follow along, I've shown you guys what you have to run for the commands. The pre-trained model config files and data files are already in the Darknet repository for us. So all you literally have to do is run this cell, Darknet detector test, that's the command, point to the data file, the config file, and then the weights that we downloaded, and then to an image. And if you actually check the pre-downloaded repository, there's a bunch of images in this data folder, giraffe, eagle, dog, person, scream, horses, a bunch of already images that you guys will have when you download the repository. So you can see that you get these warnings. This is it trying to open the image by itself, but we get a bunch of warnings because OpenCV can't automatically do the detections and open the image at the same time. In Google Colab on your local machine, it would be able to. So that's why we have imshow right after, cell right here that actually outputs the image for us, and we can see it was detected a dog with 99% accuracy, person with 100%, and a horse with 98%. And that's exactly what we have here printed, drawn on the image. And every time you run Darknet detector test, it saves your detections to predictions.jpg. So if I close this and open it back up, we should see predictions.jpg somewhere in this folder. I'm pretty blind. There it is right here, predictions.jpg. So that's where it'll save your detection on each image until you do another one, and then it'll override it. So we can see that YOLO version 4 is working, and it predicted the image in 32.7 milliseconds, which is unbelievably fast. Not even a fraction of a second, like literally just 32 milliseconds, so extremely, extremely fast. Then this cell here is just to, when you run the run all, this will fail and stop from running more cells because that requires you to have your Google Drive linked, which I will now show you. So there's two different ways you can run images or detections on images within your Google Colab notebook. You can either upload local files or access Google Drive files that you have on your Google Drive immediately to use. So there's these two different ways, two different methods, both work exactly the same. I recommend the Google Drive way just because you can easily do it and have the predictions actually saved to your Google Drive as well and output videos. So that's pretty much why it's easy to have all your stuff in one place. So first method is the local files. So you can either go here and upload directly to your session, or you can also do this command that I've shown, one of the helper functions, upload. So if you run this cell here, it's going to run the upload, and then you can see that it's trying to upload a file. So I just choose a file. I'm going to go to my downloads, and I will choose this highway image. So now I've uploaded the highway image to my root directory. So if we go back and back, we can see it's here in the root directory of the workspace. So now we can actually run our YOLO version 4 detections right on that image that I just uploaded. So we're going to go ahead and run this next cell, and it's going to do it on any image that you uploaded. So make sure to change this highway.jpg because it won't be necessarily the same. But if you took the highway.jpg from my GitHub repository, then you can actually do it straight on this image as well. So we can see 32 milliseconds. It detected all these cars and a truck. And then if we actually look, because we ran the imshow function, we can see that it indeed found all these cars and truck on this highway image, which is pretty sweet. And it did it, once again, extremely, extremely fast. So that's the local method. The next method is through Google Drive, which is really, really cool. So you can actually mount your Google Drive into this Colab workspace and access all your Google Drive files in the Colab. So we're going to go ahead and do that. So we're going to mount it. So we're going to go ahead and run this command, and then you're going to hit this link, and it'll show you an authorization code, and then you're just going to paste it in here. So click on the link, choose my account, and you're going to allow this. It just allows you to see all of your files. Copy, click the copy button, and then come back in here and paste it in, and then hit enter. And that's going to activate now that your Google Drive mounted into this notebook, which once again is really useful. And then this next cell creates a symbolic link. So instead of it being normally my space drive, I'm just going to replace this whole string path with my drive to make all my stuff way easier. Later down the line, when I refer to images, I don't only have to refer to them as my drive / images or whatever, instead of content G drive, my drive. So it just makes things a little easier. And now you can actually see that when I run this ls command, you can actually see the folders that I have within my Google Drive. So if I go to my Google Drive, I have images, videos, YOLOv4, and YOLOv4 as folders. And that's actually exactly what I'm seeing. So I've successfully mounted my Google Drive into the Colab workspace. So now I'm going to head back into the Darknet folder because we backed out of it. And I can now run on an image that I have in the images. I have this street picture, so I'm going to go ahead and actually run the detections right into my Google Drive. So this is what I said, the my drive comes in handy, because otherwise I would have had to, if you didn't do this command, you would have had to paste this whole path in here. So just a little time saver. So we're going to go ahead and run it, and we should now see that it did it on that street image. So once again, 32 milliseconds, and there's all these detections. It was a busy photo, lots of stuff going on, and there we go. We can see it. Car, people, cell phones, handbags, backpacks, traffic lights even. So you can see YOLO version 4 and the pre-trained weights that come ready to go out of the box on tons and tons of classes. So we're really seeing the power of that and how unbelievably fast it is. So you can also download files to your local machine or Google Drive from the Cloud VM. So now we're going to go ahead and do that. So to your local machine, all you have to do is run the download helper function and then point to the image or file you want to download. So it's as easy as that. We're just going to go ahead and run that cell, and you can see it downloaded the predictions.jpg to my local machine. I'm not going to go ahead and open it. You're going to have to believe me that it worked. And then also, you can do this copy command to copy files from your Colab workspace to your Google Drive. And it's going to call the predictions.jpg. It's going to rename it detection1. And you can just keep changing this and running it as you do new images. and it'll save them all to your Google Drive. So I'm going to go ahead and run this cell. And now if I go back to my Google Drive and back into this images folder, oh, there we go. I saw that appear. Back to the images folder. We now have the save predictions.jpg under the new name detection1 that I just called it. So it successfully saved it to my Google Drive. So which you can see how it's pretty nifty to use the Google Drive and everything is saved instantly into whatever folder you want. I have images folder, so that's where it's saved, and under detection1. So next, you can actually run YOLO version 4 on video in the cloud, which is something I didn't cover in my previous tutorial on YOLO version 3. So this one's actually going to be able to run video in the cloud, which is pretty sweet. So I'm going to upload a video, and I'm also going to do it through Google Drive. So I'm going to show you both types again. So uploading, I'm just going to upload this test video that I have, MP4. I'm pretty sure it has to be an MP4. I'm not 100% certain, but I would recommend MP4s. And then once it's done, we will run this command, which is similar, but it's has out file name, saving it to results.avi. So it's going to save the video showing the detections displayed to the results.avi. You can change this name to whatever you want, but make sure you run it with these flags set. This don't show one is key because otherwise it will keep trying to output the video and show you as it goes in real time, but that doesn't work in Colab, so keep away from that. So now we can run the command, and you're going to go ahead and see that it's loading up the weights, and it will actually run going through frame by frame, and it's pretty quick. So you're actually going to see that it's going through and doing the detections, and it's having it at an average SPS of 21.2 frames per second. So that's actually really fast, and it's faster than what YOLO version 3 was, the previous version. So I think it's around 12% faster. And it's going to go through, and then it will save it in this folder as results.avi. And then once again, if you want to, you can just download it to your local machine or do the Google Drive saving. So I'm going to show you right now after it downloads that. Well, I can open it up for you guys. It's still downloading actually, so we're going to go ahead and let it wait. It wants to download multiple files, allow. So let's go ahead now and go to my downloads, and we can open it up and let it play. And we can see that it indeed is working, and it actually detects the percentages on the screen as well. So it was just a 6-second clip. Once again, if you want to access this video, you actually can do that by downloading it from my repository. The link is in the description of this video. So now we're going to do it straight in Google Drive. We're going to take the video from our Google Drive. I'll show you that it's in this videos. We have the exact same video. And then we're actually going to save the results immediately to our Google Drive as well. So it's going to save it to the same folder. And once again, it's going to be called results.avi. So the difference between the command for images and video is this demo part. Demo means it's a video, and test means it's an image. So this one command replaces the previous 3 that I showed you. And it'll go ahead and save it directly to our Google Drive, which is pretty sweet. Don't have to worry about running that download command. And if you accidentally close your Google Colab workspace and it shuts down, you won't have that results.avi file saved here. Like you won't be able to access it again if you didn't download it. But running it straight into your Google Drive allows you to always have it saved. So let me just go to my Google Drive, video, and once again, we have the exact same file with the detections over top saved now directly to our Google Drive. So next, we have certain custom parameters and flags that you can add to the Darknet detector test command in order to run it with certain customizable and flexible outcomes. So you can actually have you can actually stack them and add multiple flags at once or just one. So there's this threshold flag, which is pretty cool. It allows you to run the detector and only output and show the detections for detections that are above the confidence threshold that you set. So if I run just without the flag on this dog.jpg that you already have in the data folder, you'll see that it outputs 4 detections. it has bicycle, dog, truck, and potted plant. And potted plant, it's low accuracy, and it's actually a garbage can with this tree hanging over top, and it thinks that that is a plant because of the base and the leaves, which we know it's not good, and it's actually not an accurate prediction. And as it says, it's only 33% certain that that's a potted plant. So to remove the low percentage detections, we can actually add this threshold flag, -thresh, and then a value. So this will say only output detections and show me detections above 50% confidence. So we run it on the exact same image now on dog.jpg, which you guys all have. So this will work for you guys. You'll now see that it has indeed removed the potted plant because it was under 50%. It was at 33%. And it no longer detects the potted plant, which is good because it was not a potted plant. It was a garbage can. So the next parameter you can add is output bounding box coordinates. This flag is -external output, and it allows you it shows you the coordinates of the bounding box as well as the height and width. So we're going to add that flag and just run the command. We're going to run it on person.jpg this time, and you'll see that it comes back with a little bit extra information. So here is what external output gives you. It outputs this information here. It gives you the top left corner, I believe, of the bounding box, and then the width and height, which you could use to then draw on the image, but it already does it for you. But if you were trying to create some application that needs the coordinates, this is one way to do it and to get it. So it would actually give you these coordinates here, the top left corners, and then also give you the height and width so that you could have the another corner as well. So another flag that's useful on a local machine, but not necessarily in the Google Colab, is the don't show. The don't show flag -don't show allows you to run the connector, the detector, and not show the image afterwards, because by default it tries to open the image after every detection. It tries to show you predictions.jpg. And that causes this warning that I showed you at the beginning, connection refused, and that's why we use the helper function, imshow, to output our detections. So by running this, we'll see that we don't end up having those warnings anymore. So we no longer have the warnings that we had above. So if I go up here, we had these warnings, got unable to init server. We no longer get those because it's no longer trying to open the image directly with OpenCV in the cloud workspace. So the last thing I have for today is step 9, which is multiple images at once. So you can actually run YOLOv4 object detections on multiple images just through one command. So what you have to do is you have to set up a .txt file. It can be called whatever it wants. And then you're going to do like this example here. So once per line, you're going to have a path to an image from wherever you're running the command. So if I was running the command from this Darknet repository, I could upload the txt into here. And then if I wanted to have an example, I could do it on these images in this file here, giraffe, eagle, and dog. And I would just have as my file path data/dog.jpg. But for my example, I'm going to be using this images.txt file that I have in my root directory or home directory of my Google Drive. And I will be running it on these 3 images here. You saw I ran it on a couple of them already earlier, but I'm going to show you that I can run it on all 3 at once using one command. So you can save your results as a JSON file or as a TXT file. So I'm going to do both. So I will run it first as this JSON file, and you're going to see that it runs perfectly on all 3 images. So it's got the first image, street, and then it's got the second image, highway, and actually that's all 3, I think. Yeah, that was plain first up here, then street and highway. So it's got all 3 and it did all these detections. And then if I download the result.json file and I'll just show it in folder, and I will open it with Notepad++. You can see that it returns in this pretty nice format, where you have, it shows you that it was the first image, second image through the frame ID, and then it gives you the class ID, the name, and the relative coordinates all in a JSON body. So yeah, feel free to investigate using the JSON way, but now I'll show you the second way. There's results as a TXT file, so same thing, and then you can download result.txt as well. And you can feel free to change where it saves it. So instead of out result.json, you could have that as my drive result.json, and it would save into your Google Drive. So that's, like I said, again, it makes it easier instead of having to do the download right after. And in case the workspace shuts down, you don't lose that file. So now let's go download the TXT, and we're going to go show in folder, and then open that with Notepad++ as well. So you can see this is a little bit different and not as clean. It actually outputs everything that's in that output window. So it's a little bit less clean, and it just writes exactly what's in the output window straight to the results.txt. Instead of outputting it here in the display, it just puts it into the text file. So that's it for this video, but I will have shortly coming up how to train your own YOLOv4 custom object detector as an add-on to this Colab workspace and show you how to do it completely in the cloud utilizing the free GPU. But I hope you enjoyed this video, and feel free to smash the like button and subscribe to the channel so you can see my videos as they come out. It means a lot and it helps me grow. So if you enjoyed it, please like. Thank you.